get started. Okay. Hello, hello everyone. Yeah, welcome to Yokohama meeting. So this is the auto session, and we have a 1 hour session. And my name is Chinwu, and sit beside me is Mohammed. So we'll host this meeting. And so as usual, actually, you can see this noteware. Actually, if you are not familiar, please read this. And for minutes taker, we already have Jody and Mahedi also as a backup. So thanks for your volunteer. So this is the agenda we propose for today's discussion. So we will focus on auto deployment experience update. And so the agenda pretty much tight. So for each presentation, please stick your time, maybe reserve 2 minutes for question. And we also, if we have time, we will discuss no charter item. And so we have 2 topics. So one is multi-domain service. The second is network computing exposure. So this is a current working group status. You can see actually we have 2 charter items already. In the working group last call, we actually, as a chair, request various different director review. So you will receive quite a lot of comments later on. So we plan to focus on this charter item. After this, Yokohama will schedule 4 interim meetings to facilitate the progress of this work. In addition, you can see actually we have a bunch of individual jobs, and this can be broken down into 3 categories. The first one is network computing exposure. This maybe need to align with CAT's working group. The second is multi-domain setting. The third is mobile and wireless exposure. So this is just a quick update. The current progress we rechartered in 2021 November, and focus on 2 charter items. Current progress we have now, we already published 4 RFC, and we progress these 2 working group draft. So in the meanwhile, actually, we really want to drive some auto development experience update, and so we actually auto design team actually organize 4 hackathon, and we also have 1 interim meeting. Really want to drive the progress of the 2 charter items. And at the current stage, you can see we have 6 auto deployment and 1 open source project. You can check the wiki page. We have actually open auto project. Actually, this fully open source and can be accessed by anyone. So also we have 4 new auto deployment. So in this meeting, we'll discuss the top 3 auto deployment. And later on, actually, we also socialize auto in various different working group. And thanks Luis and actually in OPSWG and Media Ops working group, TVI working group, this will be happen in this meeting. And that's the current status. And we actually, as a chair, actually already kick off the discussion to, solicit feedback for the next step of the auto. So this is just kick off this kind of discussion beginning. So we like to solicit more feedback from problems. If you are interested, you have a good idea, please propose and share your opinion. And so let's move to our agenda. The first one, I will invite IGMA to introduce Benox cascading auto deployment. So Igma, are you there?
You should be able to hear me, right?
Yes, we can hear you. Let me run slides for you, or you want to share a slide by yourself?
Let me see if the sharing here works. I clicked on the thing.
Yeah.
It's not working. What do I have to do? Do I click on ask share and then someone needs to do that? And then
Yeah, we
what
already granted.
are already taken? Okay, if this doesn't work, then I'll just use the next command and you can share and we should be fine.
Okay. Should I share? Okay, let me share. Okay.
Okay.
Oh, okay.
Okay. Now wait, now it works. Let me see.
Yeah.
Can you
It's
actually
working
see
now.
that?
Beautiful.
Yes.
Okay.
Yes.
Awesome.
Works.
Good. Okay.
Yeah, it's on
So
time. Thank you.
okay. Already wasted a minute. I'll speed a little bit up. So the reason I call this cascading alto deployment is because I'm going to talk a little bit about cascading alto and a little bit about alto deployment. And since I didn't know how to write it, it came out as cascading alto deployment. My name is Ingmar Püse. I work for Benox, and I have been working for Benox for almost 10 years now. The point here is that at Alto, we were founded as a Deutsche Telekom spin-off in 2013. And we actually, at the start, were part of the, I think it was called P4P working group at the IETF, which then got merged into Alto. And we actually went along that, as you can see, 2017. We actually already had an Alto implementation that was, I wouldn't say complete, because Alto wasn't complete at that point, or still isn't, but we do have a fully working Alto deployment, and we have by now also a customer base that would actually benefit from something like Alto being in place. And you can already see that I'm using the possibility form here. But let me go into Alto deployment itself. So what we and Alto do at Benox, we run around 20 to 25 customer deployments all around the world in medium to large size networks. We have all the necessary information that we would need to do Alto maps, and 9 of those, not all of them give us all the information, but 9 of those would actually be capable of running Alto. And why did that just go backwards? The total traffic that we could affect with this, so the total traffic is around 60 terabits that we see. The traffic that we could affect with Alto is, by our best guess, between 40 and 45 terabits, where we could actually profit from steering traffic. How much we would reduce that by, we don't know. We haven't done that analysis. But usually at least 3/4 of the traffic are affectable. Then the actual traffic that we do steer, so by exchanging information between hypergiants/CDNs, you'll see that term a lot here, which this is basically the big traffic shifters that we have out there. The traffic that we do steer is around 35 terabits, and we actually managed to reduce that down to somewhere around 25 terabits. So we're shaving off a fair bit here of traffic that we can do. And that's the outcome. We don't use Alto. So we actually do the collaboration, and we do what Alto is supposed to do, but we don't use Alto. We have 2 trials running with this for very, very small traffic shifters. We've had in the past, we've had numerous trials. Nobody ever used Alto, and it keeps doing that. That's weird. Okay, something is seriously wrong here. I'm going to use this. And the reason why we're not using, why Alto is not being used is because it's a chicken egg problem. So we talked to a lot of networks, and they said, yeah, Alto is great, and we would be using it if the CDNs or hypergiants would use it. And then you talk to the hypergiants, and they say, yeah, but we have a global customer base, and if not enough people are using Alto, we'd rather stick to our own interfaces that we've already developed. It doesn't warrant the effort to actually implement Alto into our mapping system. So both of them are on the side of the other one should move first, but neither of them moves. If anybody feels reminded of V6, then Yeah. Okay. So what we see instead is we have pretty much every hypergiant has their own way of communicating affinities or what I would call mapping information. And networks are then in the position that they have to sort of collect their information and push this out through a lot of different APIs to actually get that mapping running. It works, as you can see. We are steering traffic through that, but it's kind of a nuisance. So what I think Alto would really benefit from is something where one of the two parties, so either the network or the hypergiants, would actually draw benefit from it without having to rely on the other one of using it too, which is kind of counterintuitive since Alto is about cooperation. And how do you make a use case for something that is based on cooperation, but then you don't want it to cooperate because it needs to be deployed first? Anyway, that was the deployment part. Now let me go a little bit into the other one, the cascading, or I think here it's called multi-domain, but in the end, it's pretty much the same thing. What we do here is we have a core engine, which this is a software stack that we've started developing 10 years ago. It's pretty mature by now. The picture you have down the bottom is from the Conex 19 paper that we actually did on this. The bottom line is we collect IGP, we collect BGP. From that, we can calculate path, as you can see up there. We have the red point, which is the start of the path. You have then the orange pass through the network, and you have the green point, which is the exit point of the network. That all is set into code, and as you see down in the picture, I don't know if you can see the mouse, but on the right side of the diagram, you see that we have multiple interfaces that go to the CDN services end user control systems. Alto is one of these. Unfortunately, Alto is the only one of these that isn't used at the moment, other than for testing. But in practice, all of the implementation is there. So we can turn it on. We can produce Alto maps. We have produced Alto maps. I think we still do. So all of the implementation work of that has been done, and it has been done for almost half a decade. It's just that we can't really use it. The point here is that in order to actually build an Alto map or to build any of this mapping information, you need the ingress point, which means you need to know that red bubble where the path in your network starts. And that's a very, very heavy operation. So in the end, building a correct or any Alto map or any mapping information needs to know where the path in the network starts. The problem is that most of the paths, especially when you look at traffic that in larger networks, starts coming from a ingress point where you have an intermediate network attached. I mean, of course, you have a lot of PNIs in there as well. They're easy, but the difficult bit is when they're not PNIs. And getting that ingress point is actually really, really hard. This is an incredibly hard operation. We have a solution for this, which means we actually do this statistically on the incoming traffic, which means we're using data plane to best guess which traffic enters where in the network. And I'll not go into this a lot. The only thing that I actually want to point out here, and this is from I think 18 paper that we did on this. What you see here in the bottom right is an iOS update. And we tracked actually all of the traffic coming from the iOS update based on the different handovers. And by handovers, I mean the traffic, the neighbor that the traffic came in on for the iOS update over time. And as you can see, there is this blue chunk in there, which appears only, and it really only appears during the update time. This thing was not nice for the peering links for that handover. It completely ran them over. It just wasted all the space and pushed pretty much all of the other traffic away. It went for 3 days and then it was gone again. Having a priori mapping information, capacity information, some kind of a communication that this would actually this would happen, and I think Alto would be a good case for this, would have not gone into that situation. And this is an example. We actually see this, well, we used to see this more often. Hypergiants and CDNs have gotten better at this, and the communication has improved, but still, I think there's still room to do more of this. And finally, the second part, and this is where I'm going into the cascading path optimization or the multi-domain. We've been working on, and this is on the submission at the moment, we've been working on multi-domain ALTO, or rather multi-domain CE, we call it internally. And the point is here, you have a content that has two servers that it can deliver from. And by choosing the correct server at the starting AS, you can actually affect the path throughout the entire network path across AS borders. We've been trial running this with a friendly ISP that actually runs multiple ASs in cascaded form. So we have had all the information. And if you look at the top right, you see this 18.38% of traffic that actually goes from location 1 to location 2, which should have been mapped by the hypergiant to the other server cluster and would have had a much better path in both of the networks. So this again, and I think this is also a case for multi-domain ALTO where we can actually use this very well. This was not deployed. This is a purely theoretical approach that we've done here. So this is only math, but it is based on actual production numbers from one of our clients. Okay. And with that, I'm coming to the end. So I think on the one hand, ALTO, if deployed, especially in a multi-domain ALTO, can actually have a benefit just for ISPs without having to rely on the hypergiants and CDNs to deploy this as well. Just by using a multi-domain ALTO, we can spread ALTO deployments throughout the network. And once we have that critical mass or a mass, we would be able to then say, hey, we have a standardized format and we're already using it inside of our ISP, and we have this in lots of different places. Maybe someone else wants to hook into it too. Let this be CDNs, let this be P2P networks, let this be some case that I'm not thinking of right now. So I think that path could really help. And I'll just stop rambling here at this point, since I think I'm already over time. And I think I'll go for questions.
Thanks, Igmar, to share your deployment of data experience. And any comments from audience? So, Richard.
Thank you so much. Very quick question. So for this kind of interface, I saw that you can use CSV, you can use BGP. When you say there's this private interface between the ISPs and hypergiants, so what kind of interfaces typically they are using? So why this ALTO interface would appear to be difficult to use? Make some comments. Import some kind of features were missing, or maybe it's too heavyweight, or maybe there's some features which are missing in this interface. If you can comment.
So first of all, the interfaces are usually derived from how the mapping system of the hypergiants or the CDNs are built, which means in the end, they're all built a little bit differently, and they're all built in different dimensions. One of the things that, and this is a personal opinion right now, this is not the official opinion of Benox, one of the things that actually annoys is not the right word, but that concerns me, is that BGP seems to be used to map things, or seems to be used for mapping, whereas BGP inherently only has one dimension of having reachability. It doesn't actually have that two-dimensional space. I can map this to this, and then you have hacks of working with communities on BGP routes, and you have out-of-band BGP sessions to clusters, or you do in-band BGP where you announce selectively to individual clusters, and then you augment them again with communities. And all of this, I think, is a workaround where ALTO, since it has that two-dimensional space, it can do a lot more. As for the other protocols that we use, let this be XML or JSON or whatever. Those are usually proprietary, and they came to life by someone saying, hey, if we want to inject mapping into the if we want to inject preferences into the mapping of our infrastructure, we just need information in that format. Let's make that a JSON file, and let someone else worry about how to create that JSON file. They just need to send it to us, and that's basically I think how they
Richard,
came along.
so we run out of time. Maybe we can move on. Take it to the top, take off the list.
Sure.
Okay, thank you, Igmar again. And so the second topic is from Richard about the integration with CERN and Ruser. And Richard, do you want to control the slide by yourself, or you want to?
Probably you. Yeah, I can just say it next.
Okay. This one?
Yeah, thank you. Can I start?
Yes, go ahead.
Okay, sure. So this is a joint work with a lot of people, Mario, Mihai from CERN, and Jordi, and a large number of team, many people from Yale, from all over the places. Of course, also I want to emphasize, even though this is moving a lot in terms of implementation and so on, but still work in progress. Next slide, please. So let me first give the context about what we're doing. For this particular context, we're focusing on this thing called LHC1, Large Hadron Collider Open Networking Environment. If you want to build a mental picture about what we're doing is, you can think about LHC1 is part of the CERN infrastructure. So on the left-hand side, you can see the picture. Those are the experimental facilities. They produce all kinds of data, huge amount of data, and so on. And then our raw data will be distributed into replicated archive into all the places using a dedicated network called LHC OPN in the middle. And then it will be really distributed into a multi-domain network called LHC1. And there are the LHC1 is the topology character is 600 distributed storage systems and distributed globally in 170 data centers, essentially in 127 sites across 40 countries. The workload should be very simple to understand for this context, mostly to support 4 LHC experiments, the CMS, Atlas, LHC-B, 4 experiments, and also a newer experiment, for example, Ballet 2 and astronomy, and then there's also talking about multi-ones to support additional experiments. To also give you a sense about the traffic property, so in 2022, the total aggregate traffic, outgoing traffic on this network, for example, even only looking at CERN, which somehow, if you look at the upper right corner, you probably can find a CERN somewhere and in the lower right corner, and it produces about 457 petabytes of data in 2022. So that's essentially the scale of the network. Next slide, please. So this one will give you a sense of the software stack of the system. Layer architecture at the bottom, you can see that traditional networking layer builds all the routing, layer 3 VPN, and so on. And then above it, you have the transport layer, TCP, Cubic, BBR, and so on. And then you have some kind of essential through point-to-point transport, for example, grid FTP, HTTP, or just standard HTTP to really establish point-to-point transmissions. And then what happens is on top of it, you have data transfer scheduling, basically determining for every point-to-point transfer already given, and how to really when to transfer and how much was transmission rate for every one. And then above it, basically would be what they call the data orchestration system, which essentially determines the point-to-point transfers. For example, how to replicate, and user will download, you have multiple locations, so therefore that's the data orchestration system. And then on top, you have all the data-intensive workflows. The integration of working with CERN mostly be focusing on the data scheduling and also the transfer orchestration layers on the 2 layers. Next slide, please. Yeah, let me just first really dive into the details and to talk about how we're doing and exactly the transfer scheduling work we're doing. Next slide, please. So here is a bigger picture about what exactly it really does in terms of transfer scheduling. It's FTS, that's the standard. All the systems are using FTS and so on. Okay, let me weird. So the FTS system scheduling system actually is quite simple. So the overall is you have these 600 storage units. They all build something called a pipe, basically a source and destination. They do all of our transfers, and you essentially define something called a concurrence level. So an FTS will do is to adjust the TCP concurrence levels between every single pipe. So and what happens is you have concurrent level, let's say 60, and if you have 50 concurrent transmissions already, you got new transfer into the queue, you can dispatch it, and if you're above it, and you will not. So therefore, that's basically what's really happening. Overall, it's mostly hard. Right now is mostly hard manual configuration about concurrence levels and so on. And oftentimes they really try to really avoid congestion on sorted units. Next slide, please. So here, what Alto FTS is doing is this essentially called the application-defined networking. The basic structure is this kind of layer architecture. So what happens is you can have diverse network settings, and then you really have this the architecture from FTS is you have this universal, minimal deployed TCP congestion control. This one is universal available everywhere because it's multi-domain. So therefore, you want universal available. And you also want to build on top of TCP, which is fast, efficient, robust building block. So therefore, you have congestion control. So therefore, you don't have congestion collapse. You can allocate whenever extra bandwidth, you can take advantage of it very quickly. But then if you're using TCP and for a given number of connections, you essentially have a single resource allocation model, basically computed, for example, if somehow maximum fairness with BBR and somehow it's only a single resource allocation. But what you want is have diverse high-level resource models. So what we're doing is taking FTS and extending it into Alto FTS to have scheduler, and we'll be able to provide diverse high-level resource models in this overall setting. Next slide, please. So here is the bigger picture and what will look like. So you have the multi-domain networks. You have all the pipes, for example, pipe I from source destination goes through 3 networks. And then what happens is you have this controller. It's also called a TCN. It's very lightweight control plane. And then what happens is all autonomous systems, for example, S1, S3, they have links which they want to control the resources. So what they do is they essentially put their resource models into the resource model on the lower left corner. An example of resource model is on okay,
you only have 2 minutes.
Okay, yeah, let me try to finish this part. Okay, so therefore you have the resource model over there, and then the resource model is specified into the controller. And then what happens is also is you're going to have the controller, the user auto to collect visibility. For example, if you do the transfer from pipe I, then what kind of links will be really utilized? Then you have scheduler to control the concurrence level and also time multiplexing. Next slide, please. So here's a very quick example, and even if this one get across, you probably get a sense of what it does. So here, the first level is resource model. For example, you have single project. For example, one experiment. You want to specify for project 1 and physical link 1 should have less than or equal to 5 gig. Physical link 2 will be 10 gig, and physical link 3 will be 10 gig, and so on. So therefore, you specify all the resources. Then what schedule does is very simple, and you can collect how much data you're transferring on pipe 1, pipe 2. For example, pipe 1 3 gig, pipe 2 is 9 gig. But then you also use auto to really get the visibility. So, okay, I'm really, for example, pipe 1, I'm using link 1, 3, 4. And for pipe 2, I'm using link 2, 3, 5. So therefore, you get all the visibilities. Therefore, you can say, hey, for physical link 3, I'm using a total of 12 gigabytes. Therefore, you're above your resource model. So therefore, you can have a penalty. You should really slow down. Next slide, please. So basically here is how we get visibility. Right now, we're getting visibility using 3 approaches, looking glass and other ones and so on. So next slide, please. So the first step, next slide, please. So right now, this is only give you an impression of how we're doing right now, where for current deployment implementation, we only get visibility from first half from CERN. So therefore, we can know about the CERN, for example, 6 outgoing links, and we know which one is using. So therefore, we can get visibility. We map all the traffic into it. You're doing all the download. We map into the correct project. Next slide, please. And then we do this very fancy scheduling algorithm, which we don't go to the details. It's integrated into FTS 3.12, 12, and we modify the resource model. We integrate it with all implementations and so on. So therefore, that's basically what Auto does. Next slide, please. Yeah. Can I just use like 2 minutes? I'm going to rush through the rest, and then I can wrap up. Would that be okay? I think I can get done in 2 minutes.
Okay.
Sure. That will give you a sense of Auto FTS. Now let me go over what Auto Rusho does. So Rusho is orchestration system, basically trying to really pick downloading, where do I download, replication, where do I replicate to, and there's a system, it's trying really using a sorting algorithm. So what we're doing this moment is we're using Auto as a sorting interface, a uniform sorting interface. Therefore, you can have all kinds of visibility about all the distances, and we use Auto as a single unified interface. Next slide, please. So here's one very simple example. So the key idea here is our implementation deployment is we introduce language called the sorting expression language. For example, you can look at the step 2 over there in the middle. You can see you sort by AS hop count, and then by delay, one way delay. And you must select, for example, by the EU, and then you sort all replicas and use and give the input into Rusho. So this is essentially the Rusho select files. So therefore you can sort everything according to interfaces and then select all the replicas which you want to do. Next slide, please. Yeah, so this is basic configuration. Of course, right now, the first step in terms of deployment, actually, we're using simple one is using geo-IP. So therefore, for every device on the left-hand side, you can see we can map into a geolocation because we all know the 600 nodes. Right-hand side, we can really compute geolocation as unified interface. So therefore, we can know what's going on. So therefore, give it a unified interface. Next slide, please. Yeah, I'm done. And so basically, all these other 3 interfaces. Next slide, please. I think I'm done. Yeah. So this implementation and yes, yeah, that's basically people can take a look. Yeah, I'm done.
Yeah.
Sorry.
Thanks, Richard. So let's move on. The next is Luis, right?
Hello, everyone. So I will comment on the trial or the pilot that we are doing for integrating Alto with the Telefónica CDN. So next, please. So just as a reminder, the rationale for this pilot. So essentially, the point is that the main objective of whatever CDN is to optimize the delivery, the traffic delivery. This is also applicable to the Telefónica CDN. Telefónica CDN is providing content live and video on demand for events, films, and series, and so on so far. Today, the way in which the Telefónica CDN was working was collecting, uploading manually different topological maps. So this produced that along the time the real view was somehow lost. So that there were inconsistencies in understanding where the different users were in the different POPs, because we are moving prefixes or there are changes in the network, there are updates, and so on so far. So the objective of this pilot was essentially to leverage on Alto for retrieving automatically an up-to-date view of the topology, and with that, taking the proper decisions at the time of delivering the traffic. The idea is to automatically adapt the logic of the CDN in such a way that the CDN can be aware of topological changes, congestion, and so on so far. This was presented before in IETF116, 115. Was presented the pilot. So I will provide here a status of how it's now. Next, please. So the pilot is running from October last year up to now. 1,600 subnets are already retrieved from the real network, but we are still facing a number of issues and a number of challenges. The first one is something that is collateral to Alto, and is the point that one of the vendors, the router vendors in the backbone of Telefónica Spain, needs to, we need to update the operating system of these routers in order to have full support of BGPLS across the different layers of the backbone. We have till now partial support. So we started to do this deployment for the rest of the layers in February, then in March. But in March, we detected some issue in some part of the network impacting another service that was affected. So we rolled back the deployment. So we are now in the process of completing once identify the full issue and so. The second point is actually related to Alto itself, and was that we discovered some flapping in the sessions between Alto and the route reflectors. So let me say, this was commented in the previous updates, not here, but the deployment. Basically, what we do is to establish a BGPLS session with some route reflectors and a BGP session with another route reflectors for different purposes. The BGP is for retrieving the prefixes of the customers, and the BGPLS is for retrieving the information of how the different endpoints, the CDN endpoints, and the users are connected. So coming back to the point, there was some flapping in this connection between Alto server and route reflectors, and there were two effects. We received TCP0 windows in Alto from the route reflectors. This point is under analysis, could represent an issue about congestion of the route reflectors, so we are trying to investigate that. A discussion has been open in ExaBGP. We are using ExaBGP as BGP speaker of Alto for connecting to the route reflectors. So yeah, we are investigating this point. The second point was that when receiving the information from the network in Alto, there was some overflow because of the amount of messages being received. So there were some processing issues, and this was essentially due to the fact, to the way in which we were processing the data arriving ExaBGP. So this triggered an initiative for re-architecting Alto, in fact, for architecting how we process the messages that are received in ExaBGP. And now we are solving this and I mean, having a more efficient way of processing the data. And the third point is, okay, there is the fact that when at the point that we connect Alto, we have a full retrieval of we connect Alto to the route reflectors, we have a full retrieval of the topology. But once we have done this connection, then we only receive the updates. So because we are in a POC, in a pilot, we are trying several things. So it's somehow, I mean, would be convenient to have more often the full topology. So we are trying to understand how often would be convenient to retrieve this full topology in order to not impact the route reflectors. So this is also part of the pilot, and we expect to report in the next IETF the further status. So next, please. So the final one is ongoing next steps. Is somehow is a summary similar to what we did in IETF116. So the main purpose is to understand how to consume Alto information, how often we need to retrieve from the logic of the Telefónica CDN the information from Alto, and then from Alto as well the information from the network. Second point is to continue analyzing the information received to understand the dynamics in the production network. So how often are the updates and so on so far. Debug issues that could be found during the process, like the ones of the TCP0 window and whatever I commented before. And we have this dependency on the resolution of the operating system of one of the backbone vendors, just for having all the BGPLS, and then with that, all the view of the topology in Telefónica Spain. So regarding Alto, we are also progressing in the productification of Alto. So this will be an in-house development, and we are working on such development. That is not only the Alto itself, but also the logic in the Telefónica CDN for consuming Alto. Well, that will be the second point. The topology, load automation of the topology to be consumed by the Telefónica CDN. Regarding the work more in IETF, so the idea is to keep the pilot documentation up to date. There is some information now in the Alto wiki, so our idea is to continuously update as long as we progress in the pilot, and for sure identify gaps, issues, improvements that could be worthy to work here in the working group, like security aspects and some other aspects that we are identifying. With this exercise, with this pilot, we are also planning new pilots around the discussion in Telefónica, and probably the next operation in Telefónica where we will try to do this integration is in Brazil. This is yet under discussion, but it's probably, it will be like that, and hopefully I can report you on next IETF. That's all from my side. Thank you.
Thanks, Luis. So any question? Let's move on. Okay, Martin, go ahead.
Hi, Luis, thanks. This was very informative. What, if anything, do you need from this working group to move forward? Or are you just tuning basic Alto? Like, do you need SSC? Do you need to transport instead of SSC? Do you need multi-domain, or none of the above?
Well, in this particular case, because the Telefónica CDN, because everything is under the domain of Telefónica, somehow this is an environment under control. But if we think in whatever other service, all those services will be multi-domain. So you access a YouTube video, or you access whatever cloud for for deploying whatever thing or for accessing whatever content. All of that brings the multi-domain scenario in place. So just for giving you some numbers, around the 80% of the traffic from Telefonica is coming from outside Telefonica. So if we want to extend this kind of optimizations, so how this is driving us to the multi-domain scenario sooner or later. Apart from that, probably there will be some improvements to Alto. I mentioned here the security. This is something simple. The way in which we are building the PIDs, for instance, is based on the router ID. So this information is sensible, so we cannot expose this information. So working in ways of securing the interaction with Alto, not only Alto itself, that is also important. So how the customer access Alto, how to protect, for instance, the EOS attacks from the client to the Alto, and so once we expose to outside to external applications, let's say, we need to secure the way in which they can interact with Alto, and also even securize the information from Alto. So there will be aspects that are more, let's say, short term, and others that could be a little bit more mid-term that should be addressed. Probably something that we can do is maybe summarize all of this and document in the wiki and probably take in one of the interim meetings of Alto.
Thank you.
Thank you.
Thank you. So Gaukai, you have question? Okay. I think Jody, you can stand up and move on. Is this one? Right. Okay. Go ahead.
So we're going to be discussing in the next couple of sessions two proposals. One is the multi-domain and the other is compute. So the multi-domain, this is also a multilateral effort by some of the leading leaders of some production networks in Europe and the US, as well as some ISPs. Myself, I'm Jordi Ross. Next one. Yeah, so RFC 7971, which is deployments, states that Alto is inherently designed for use in multi-domain environments. That's basically because the networks that we're dealing with are built networks of networks. So inherently, whenever you try to extract information from the networks, you're dealing with multi-domain. Now, the standards, the Alto standard focuses on single domain. So this effort looks into the capabilities we need to bring into the standard in order to support the inherent nature of multi-domain networks that we're dealing with. And that case becomes even more obvious when you start looking at the edge, which is basically a heterogeneous environment made of networks. So next one. Yeah, and just to position the problem. So in multi-domain, so you start with multiple ASs, and if you have multiple Alto servers deployed in each AS, each one will have a local view, or just the local view of that AS, but it will have no knowledge about the other ASs. So, for instance, path reconstruction becomes challenging because you don't have knowledge about the other ASs. Measuring the cost of a path becomes then also challenging. So this effort looks at addressing this point. In this, what you see here on the right side is an example of multi-domain network that Richard mentioned, which is many networks globally interconnected, basically science networks in America, Europe, Asia, Australia, and facing this issue about multi-domain and having partial information, basically. So next one. Yeah, I'm going to skip this one. It's kind of the same. So next one in the interest of time. Yeah, this is coming from the ESNet folks, and it's just another example of in this case, they have 3 domains, and they all have their own constraints. So XIs here are the bandwidth allocated to going to a certain destination, and as it goes through the different links, you have different constraints. But these constraints are only known to each member network, each AS. So you don't have a global view. And so if you want to determine what's the actual capacity for that path, you need to bring the global view of the network. Now, this deals with one level of bottlenecks. If you go to the next one, this other draft talks about bottleneck structures, actually addresses the multi-domain problem when actually and revealing the hierarchical structure of the bottlenecks. But the point here is that there's partial information, and we need to come up with a way that the Alto server can propagate this information to gain global knowledge and be able to provide a global understanding of the network. So yeah, so in this view, if we look at, for instance, the problem of path reconstruction, in routing, information propagates upstream. What that means is that when an AS is an Alto server belonging to an AS is being queried and it's being given a path, source destination path, it can figure out from the destination the next hop, and so it can actually tell the downstream path. But it cannot figure out if you provide the source where it comes from. That's inherent to how BGP interdomain routing works. So what we're missing here is propagation of information downstream in order to be able to get the full path information. So moving on to the next one. Yeah, and so here there are a couple of approaches. One is to propagate this information horizontally, so from AS to AS, so then each AS can gain global knowledge by passing this information. The other is to provide this information vertically, so you would have an aggregator Alto server, which would be using an Alto client, querying each Alto server from each of the ASs to aggregate the information. So if we move to the next one, we see a high-level view of these two approaches. One is information propagating from AS to AS, from one Alto server to an Alto server horizontally. This will allow you to compose the full path. The other approach is to use an Alto client with an Alto aggregator server composing composing the full path by querying in sequence the various Alto servers. Next one. Another challenge being discussed in the draft is incremental deployment. What happens when one of the ASs hasn't been upgraded with this capability? So in this case, the idea would be to provide guidance. For one, how to detect the goal is the ingress point when one of the ASs does not participate. So in this example, suppose that ASA does not participate. So how does ASB? How can ASB reconstruct the path, the upstream path? One option is you could query all possible paths and then eventually figure that out. But what if second challenge? What if it ASA actually does not get any response, right? So some recommendations, some guidance here would be useful as a working group. Yeah, next one. And this is a list of drafts that have been written about this topic within Alto for quite some time, I guess. Yeah, just to bring them together. And then the next one. So the next steps, we're going to be having a series of interim meetings. So this will be discussed in one of the interim meetings, and then also involving operators into discussion. I think that's it.
Okay, thank you.
Thanks.
Any question from audience? Okay, let's move on. Next one is Luis.
Hello again. Yeah, in this set of slides, we will comment about the network and computing exposure. We have only 1 minute, or no? No, one more. Okay, yeah. Good. So next, please. So this slide is just for positioning the different drafts. We will comment on the two in yellow, the one which is called service edge and the other one which is called service functions. And all of them somehow share a relationship with another draft, which intends to position ALTO as an IETF network exposure function. But we will concentrate in these two, which are the ones related to the network and compute topics. Next, please. So for the one called service edge, so the problem statement is essentially the fact that now operators are deploying multiple data centers or as compute nodes and so. I mean, we have different compute capabilities spread across the network. So the purpose here would be to leverage on ALTO for assisting on the identification of the proper data center, the proper compute facilities for whatever service purpose. One could be the instantiation of functions, or essentially that could be the kind of cases that we can cover here. So it would be the point to integrate that information that could come from the compute infrastructure on identify where this compute infrastructure is attached to the network topologically, and then expose this information, combining information from the network and information from the compute side. As the solution, well, we do foresee that there could be a potential, well, there would be, as I said, the need of extending ALTO by including these kind of metrics. Also, the metrics, as I said, can be combined with the network metrics and with the current outcomes from ALTO, like the performance metrics related to the latency, bandwidth, and so on and so forth. Regarding the updates in this current version, we have added two use cases. One about open abstraction for edge computing, and another one for optimized placement of microservice components. Also, Jordi has joined as co-author of the draft. And just for commenting the figure that you can see on your right, essentially that will be the kind of integration that we are proposing, something basically combining the information, topological information that we could collect through BGP, BGPLS, as we commented before, plus the information that could come from compute managers, like Kubernetes, OpenStack, these kind of things. So next, please. The next one will be presented by Jordi. So.
Yeah, so why is this very important to us, right? So, so in the traditional architecture, we had compute confined to the data centers, far away from humans, if you will. In the new architecture, compute is actually spread throughout the path, communication path, basically, right? Getting closer to humans. So we have compute from the data center all the way to the UE or the final device. And so now the problem becomes one of placing services and selecting services. And the problem becomes one of finding the right trade-off. So on the data center, you have a lot of compute power, but high latency. Closer to the terminal, you have lower power, computational power, but lower latency. And so that within that trade-off arises a complete ecosystem of problems of finding the right place where to deploy your services, and once deployed, which ones to select for the specific workload. And so you can start seeing the importance of bringing visibility in order to be able to optimize this problem. So at the bottom of this diagram, then we have three instantiations of the application space, problem space. Again, application service placement, typically this would be driven by the content provider, the service provider. Then once it's deployed, you have problems like application service selection and path selection, typically driven by the application itself. Let me just maybe mention an example that it's very important, and that, of course, we have a lot of interest in being able to solve AI training. So currently data centers are running at capacity. And as we migrate to AI, whether it's training and inference, there's a need to actually leverage the edge to these computations. And so there's a whole set of problems dealing about distributed AI training and inference, bringing the workloads to the edge. And also actually some studies actually show how you can actually reduce by 50x to 100x actually in terms of energy efficiency in doing so. So very important also to be able to reduce the energy consumptions of these massive workloads. And so then moving this to the edge requires figuring out again how to do the placement in an environment where actually typically the network becomes also the bottleneck. Figuring out where are the GPUs, the storage, the memory, and the bandwidth and the latency altogether. So, of course, other use cases that have been discussed widely in the working group, XR, VR, and all the applications enabled by the Edge Cloud as well. So, back to you, Luis.
Okay, this introduces the second draft, the one called service function. Here the problem is to address, before we were addressing the problem of the infrastructure, so where the infrastructure is located and what are the combined metrics for the infrastructure itself, here will be related to the service functions. So the different services are typically implemented in a number of microservices that are deployed in different points in the network, usually creating graphs or service chains, let's say. So the idea here would be to identify the suitable path for whatever service chain, so in such a way that we can address the proper service instances, with the proper metrics, right? So here again, the proposal for the solution would be to leverage on Alto plus extensions to assist on the identification of the best chains, so we're combining information of network and service function. There are extensions foreseen for collecting information from the service functions. I added there a number of drafts, like IETF path, that would be the extensions foreseen. We do foresee extensions for Alto path vector, for unified properties, and also regarding the mechanisms for collecting the service function information. Is here where there are some other drafts that are reflected there. So regarding the figure, you can see similarities with the figure before. So in this case, instead of collecting information from the cloud managers, we will be collecting information from the service function orchestrators or the network function orchestrators. Regarding the updates, and apologies for the mesh before. So we have added here some reference to CATS framework as additional use case that could motivate even this work, because CATS could be benefited for this information that we could provide it via Alto. And also we added references to different mechanisms for conveying information related to the service functions, like RFC 9015 and a couple of drafts that deals with the propagation of service function information in ISIS and OSPF. Next, please. So some examples of potential cases of interest. So the idea would be things that we could consider would be to identify characteristics from a PID to any instance of a service function type, or between service function instances in a chain, or essentially to identifying what could be the characteristics between the different components in the chain, not only from the customer perspective, but also from the different microservices, in order to identify what could be the better, let's say, path to follow later on. Next, please. So as a summary, Alto provides value to this problem space. Alto is an off-path solution, so it's solving this problem space from that perspective. The exposure towards applications is crucial for the applications to from themselves to take decisions on what is the different delivery path to follow, and for orchestrators and managers also to understand where is more convenient to instantiate the different microservices. So somehow we address the two kind of consumers, right? But basically the point that Alto could fit different not only applications but also network elements or controllers to take steering decisions, and it's essentially an exposure function, and this is what we are trying to promote with these ideas. That's all. Thank you.
Thanks, Luis. Thanks, Jody. So, Yuan Dongyu, do you want to make comments? We cannot hear you.
Okay, thanks for the work. And here's the question: that talking about a specific way to collect computing status and the granularity for computing resource description, and interested in what's the difference between the auto way or maybe a haystack mechanism applied in DNS plus GSOB, or some cloud load balancers, and maybe a Prometheus applied in a Kubernetes? And that's a question. Thanks.
Thank you. I think the main difference or the main advantage of Alto is that Alto can aggregate all those metrics. So how, taking directly from the cloud managers also could be, the information could leverage in Prometheus or whatever. The point is that Alto can aggregate that from a topological view, from a topological perspective. So that would be my answer. Not sure if I got properly the question. So if not, please let me know.
Richard? Richard, go ahead.
Luis, I think this is very interesting. Can you go back to one slide when you talk about the potential information exposure? Yeah, over here. This is very interesting because one feature in Alto is introduce a concept called PID. Basically, it's abstraction of a set of nodes. From here, are you talking about potentially even making a PID as abstract, essentially some kind of like abstract service ID, for example, in Kubernetes? And therefore, you really define an abstract, for example, then the membership of the PID can become dynamic. And then the property to this PID becomes, so essentially PID becomes a service instance, service name. The benefit of using this abstract thing, of course, compared with DNS would be only query where there's no push interface in DNS. And here Alto does have a push interface where you can push all the modifications to that. Would that be something you're thinking in terms of difference? Or maybe I don't fully get it.
Yeah, here we need to explore a little bit more how we could define these kind of PIDs. So you look at these drafts propagating information about service functions for ISIS or SPF or the other RFC that I mentioned before. Essentially, they are propagating service function identifiers. And the primary idea that came to my mind was somehow we will understand where these service function identifiers will be attached to, because we will have the IP of the data center or the IP of the PE that is connecting these functions. So probably we could take that that way of extending the PID, just associating to those IP addresses the identifiers of the service function. But this is something that requires further development, further work. So.
Okay. Yeah, because the reason I'm thinking about this one is typically, for example, in Kubernetes, what you do is you're using essentially some kind of a pub subsystem, right? For example, I CD over here, which is a key value store, and main function is list and watch interface. So therefore, you list all the instances, and then you start watching, and then all modification will be pushed into the client, for example, on the Kubernetes on the devices. So therefore, then you really have a push interface, which, because I'm reason asking is because I'm seeing how important it really is for the transport interface. But I can talk to you more offline. Great.
Okay, thank you, Richard.
So thank you. We actually wrap up this meeting. And for people who are interested in this draft, please review this draft, give the comments. So we will continue to discuss direction of the Alto. If you care, actually, please share your comments. So thank you. So see you next IT meeting.